So I only do it when it's illustrating a very important point. So yeah, I'm pretty fast. I don't think.
Yeah, everyone who does it just gets no.
All right, let's see. So it is the 20th. All right, so we are in the process of factoring, and factoring is trying to figure out what times what gives me this. Factors, what times what. And so we did this yesterday. When you look at these two terms, what do they have in common? Okay? And so I can take out that x. I can undistribute that x. And if I take out an x from each of these, what's left behind? A 2x minus 5. Okay. So my question to you is this different?
No. Yeah.
So let's take a second and really compare A and B. They both have a coefficient of 2. This is x being squared. This is this thing being squared. They both have a minus and the 5, and they both have this multiplied thing. Are they different? They are functionally equivalent. Okay? If I said x is the same as a minus b. If I said x is the same thing as a minus b, and you took that a minus b and you plugged it in, wouldn't you get that? Okay. So not only can we factor out maybe just an x that matches, that is common to both terms, but when I look at this, I see one term and another term, and I say, hey, what do these have in common? What do they both have? The a minus b. And an a, do they both have the a minus b? Yeah, so I can actually take out not only just a variable like x or y, but I can actually find the GCF of the whole, you can take the whole group out, all right? They have a common factor of a minus b. They both have the a minus b. So I'm going to pull that a minus b out in front. What's left behind? 2. What does this mean, a minus b quantity squared? Yeah, it was a minus b times a minus b, right? And if I'm undistributing one, I'm going to get rid of one. Yeah, so there's an a minus b left over. And then minus 5. So those cancel out, and we left with the minus 5. Now, can I do a little bit of cleanup inside here? Yeah. I can distribute the 2. So 2a minus 2b minus 5. This is factored. Ladies and gentlemen, this is what we're doing today. So yesterday we did the greatest common factor. Now we realize, hey, maybe just not the x, but what if the x was a whole group, what a whole sort of binomial or trinomial that they had in common? We can take out entire groupings of stuff, okay? Which leads us to factor by grouping, which I know that many of you know how to do because I've been looking at your work, and a lot of you are doing factor by grouping, which is wonderful, okay? So let's try a few here. Example 1, factor the expression. Example 1, factor the expression. So factoring means figuring out what times what equals this thing. And greatest common factor is one of the best methods for factoring. In fact, it's how we do all factoring, really. Greatest common factor. So we're still doing the same thing we did yesterday. We're looking for the greatest common factor. Now, we are unmultiplying, which is the same as dividing, okay? So just for today, I'm actually going to show that stuff because I think that sometimes it can be helpful. So when I look, I have one term and then a whole nother term. Terms are things that are connected by multiplication. So all of these things are connected by multiplication. And over here, we have the negative 9, and those are connected by multiplication. Okay? Negative 9 times a grouping. So when I look at that, what do they have in common? Sure. A squared minus 15. They both have an a squared minus 15. So I am going to undistribute that and see what's left behind. So undistributing is the same as dividing. So I am dividing it out. And the reason I like to show this is because we're going to do this next, actually. We're just reducing. What's a squared minus 15 over a squared minus 15? It's 1. And so it leaves behind the 2a. And over here, minus 9. Done. Yeah. That's it. Is that easy or hard? Do you have to show this divide step? Hells no. So B is a little trickier. So I like to recognize that this is one term times another, and another term. Okay. And then when I look at those two terms, I'm going to ask you, well, what do they have in common? They both have the whole group, 3x minus 2, and we need to figure out what's left over when I divide it away, when I undistribute it, okay, when I pull it back. What's left in the first term? X squared, very good. And what's left over here? Plus 1. Thank you for not saying nothing. This is why I show the divide step, because what is 3x minus 2 divided by 3x minus 2? Just like 3 over 3 is 1. This is also 1. Does x squared plus 1 factor x plus 1, x minus 1?
Yeah.
It would be x. The plus. Yeah, you can't do plus or minus. It's a positive 1.
Correct. Good. Yes. Positive 1 times negative 1 would give us negative 1, not positive 1. This is not difference of squares, right? Okay. So be careful. All right. Over here, what do they have in common? Okay. And if I undistribute, if I pull out that b squared minus 4, what's left behind? Very good. Are you done? No. What else can you factor? This, b squared minus 4, double bubbles. What does it double bubble as? b plus 2b minus 2. Always looking to see if we can get down to those prime factors. Okay. All right. Okay, do you have any questions on these? Those are pretty easy, right?
Yes.
Okay. Example 2. Factor the expression. Example 2. Factor the expression. How many terms do you see? 4 terms. 4 terms. 4 terms. When I look at the 4 terms, I see 1, 2, 3, 4 terms there. When we have 4 terms, a very common strategy for factoring is factor by grouping. So that's this method that we're using. And it is just a strategy. And factor by grouping doesn't only work when there's 4 terms. It works sometimes. It doesn't work out, but sometimes it works for any even number of terms. So it could work for 2 terms, or 4 terms, or 6 terms, or 8 terms. Okay? Factor by grouping is a great method. And guess what? It's the same thing over and over again. It's looking for a GCF over and over and over again. So I know some of you are noticing this is 2x minus 3x, which isn't that just a negative x? It could be. We're going to show you it works this way too. So for factor by grouping, here's the method we do. We part the Red Sea. Yeah, no, we're looking for the first 2 terms, and then you'll notice the last 2 terms. So we split our terms apart. And what I'm going to do then is take these first 2 terms and look for the GCF just in those first 2 terms. Looking at those first 2 terms, what do they have in common? X. So I'm going to factor out that X. If I factor out the X, what's left behind? Plus 2. How do you know if you did that right? You can just distribute, right? X times X is X squared. X times 2 is 2X. Good. We do the same thing for the last 2 terms. I'm going to ask myself, hey, what's the GCF? Negative 3. I love how you took the sign along for the ride. Negative 3. If I take a negative 3 out of each of these terms, what's left behind? X plus 7. How do you know you did that right? Distribute. Negative 3 times X is negative 3X, and negative 3 times 7 is negative 21. So we're good. Now I'm back to 2 terms just like we had before. And once again, I ask you, now, what do they have in common? Nothing. Okay.
So we did a round.
I maybe made a typo. But, well, I can't go any further. I'm stuck. This is as far as I can go. Okay? So let's try another because that blew up in my face. So let's try B. We have x cubed minus 3x squared plus 4x minus 12. I think this was supposed to be a 7x. We'll pretend. It doesn't always work. Factoring works sometimes, but not all the time. That's just how it works. All right, so same idea. I've got 4 terms, so I'm going to split them into 2 groups. And I'm going to look in the first 2 terms and say, hey, what's the GCF? X squared. Very good. If I take out an x squared from both of those terms, what's left behind? Very good. X minus 3. Now, looking at the last 2 terms, what's the GCF? Just a 4 or positive 4 or negative 4? Positive 4. You always need a sign. So we're going to take out the positive 4, and what's left behind? X minus 3. Okay, very good. Now this is going to work. Now I have 2 terms, and we ask ourselves one more time, what do they have in common? X minus 3. And if I take out that x minus 3, what's left behind? X squared plus 4. Can I factor any more? No. Can I factor x squared plus 4?
Yes. No, because it's positive.
It's not difference of squares. Very good. This is nothing. It doesn't factor. Okay. If it was x squared minus 4, that you could do. X squared minus 4, you could factor. Difference of squares. All right, letter C. AB plus 3C plus BC plus 3A.
You rearrange it.
You rearrange it. Oh, interesting. Yes, we are allowed to rearrange terms. So, how do you want to rearrange it? What'd you say, Adrian? Okay, so Adrian says the middle terms and then the outer terms, like that. Okay, so let's do that. I'm gonna rearrange 3c plus bc plus ab plus 3a. Okay. So now we did a little rearranging. When I look at those first two now in blue, what GCF do they have in common? C. And if we take out the C, what's left behind? 3 plus B. All right. And then looking at the GCF of the last two terms, what do they have in common? A positive A. If I take out the positive A, what's left behind? B plus 3. Are these the same or different? They're the same. Okay. Let me ask you another question. If it was 3 minus B and B minus 3, are those the same?
Negative.
They're opposites of one another. Yeah, very good. Okay, good. All right. So now looking at what these two terms have in common, what do they have in common? B plus 3, and what's up behind? C plus A. Very good. Okay. Raise your hand if you think you've got this. Yeah? Okay. Last one. Which hopefully you've already done. All right. What do they have in common? B squared. What's left behind? Good. And the last two terms. A positive 3 comes out. What's left behind? All right. And then now they both have A minus 4. And what's left behind? B squared plus 3. Does B squared plus 3 factor? No, it's not difference of squares. All right, awesome.